volumetric analysis, and we're specifically going to look at titration technique. So our learning intention is to discuss apparatus used in volumetric analysis along with correct titrometric analysis techniques. So, to start, a titration is a laboratory procedure where a measured volume of one solution is added to a known volume of another solution until the reaction is complete. In titrations, we've got acid-base titrations, we've got oxidation-reduction titrations, and we've got water titrations, and they involve the use of the following equipment: a graduated cylinder, a volumetric flask, a pipette, a burette, and a conical flask. And let's look at each of these individually now. So, the graduated cylinder is the first one. The graduated cylinder, it's not very accurate and should only be used ever for approximation, and should be rinsed with deionized water prior to use. A volumetric flask is used to make a solution of a known concentration. So it's used to get solutions of accurate concentration or a standard solution. The volumetric flask, it has a mark on the side called the graduation mark, and it indicates when an exact volume of a solution has been added to the flask. The volumetric flasks come in different sizes. They come in 250 centimetre cubed, 500 centimetre cubed, and 1 litre. They're the most common ones. Before they're used, it should be rinsed with deionized water only. When the solution comes near the graduation mark, it should be added dropwise until the bottom of the meniscus is in line with the graduation mark. And that is so key. The bottom of the meniscus must be in line with the graduation mark. So here is what we mean by the bottom of the meniscus. So the bottom of the meniscus is this line along here that I'm just going over in yellow now. So usually there's a little dip in your liquid level, and it's at the bottom of that dip where the bottom of the meniscus is. So that's important to know. And also in a volumetric flask, it's usually inverted several times. 20 is usually a good figure, and that's to ensure a homogeneous solution. The pipette is next, and a pipette is used to suck up a certain volume of a liquid from a container. Before it's used, it should be rinsed with deionized water, and then the solution it is to contain. And the reason it's rinsed with the solution it's to contain is so that there's no dilution of the solution by the deionized water. A pipette is filled by suction using a pipette filler. So there's different types of pipette fillers. There's ones with buttons, or there's ones that might be more common for use in school that have a wheel on it. It's really important to ensure that there's no air bubbles in your pipette. And when discharging liquids out of the pipette, keep the tip of the pipette in contact with the side of the flask so that it runs down and doesn't create any splash. And at the end of discharging your liquids, it's important to touch the tip against the side of the conical flask to ensure you get all of the liquid out of it. However, when you look at the bottom of your pipette, there will be a small piece of liquid left in the bottom, and it's important that you do not blow out that last drop from the pipette, as the pipette is calibrated for that. So once the liquid stops flowing out, you've pipetted as much as you need, so you don't need to blow out that last drop. Next up, we've got the burette. So the burette is a long, narrow tube that's closed at the bottom by a tap. Before use, a burette is rinsed with deionized water and with the solution it is to contain. Similarly for the pipette, this is so that there is no dilution of your solution. A solution is added to a burette using a clean funnel, which is removed when the solution has been completely added. So you put your funnel in the top of your burette, you pour in with your funnel and remove the funnel once that's complete. You usually ensure that you fill to the 0 centimetre cubed mark, again ensuring the bottom of the meniscus is in line with that mark. So usually people will fill above the 0 mark and then drain, turn the tap on the burette to drain it out. It's important to ensure that the part below the tap is filled with solution and to ensure there's no air bubbles. So that's the reason why people will fill above the 0 mark and then drain down to it, because that will ensure that the part below the tap is full. Any excess drops at the bottom of your tap should be removed by touching the edge of a beaker against the tip. Sodium hydroxide should never be placed in a burette, as it can solidify and cause blockages. And only if a solution is highly coloured should you read from the top of the meniscus. So in general, you'll read from the bottom of the meniscus, as I've highlighted here, if it's a colourless solution. But if it's a coloured solution like potassium permanganate, which has a deep purple colour, you must read from the top of the meniscus. Lastly, let's look at the conical flask. So before we use a conical flask, it should be rinsed with deionized water only. It should not be rinsed with the solution it's to contain, because you don't want to have, you want a white tile is placed under a conical flask so that you can see the colour change clearly. And the shape of the conical flask allows for swirling without spilling, and also allows any droplets to be washed down into the flask. And usually it is necessary to wash down the walls of the flask with deionized water. So here's some main tips. The acid will always go in the burette and the base will always go in the conical. So there's a few ways you can remember this. You can remember it as acid in the attic, base in the basement, or you can remember it as A, B, B, C, acid in the burette, base in the conical. And there's 3 titrations usually completed for each experiment. The first titration is a rough one and its figure is usually ignored, and you get the average of the next 2 titration values to be more accurate. Now usually in an exam question they'll just give you the average titration figure, but if they don't and they give you 3 titration figures, you should discard the first and get the average of the second 2. So just to reiterate again, there's 4 main types of titrations. There's acid-base titrations, potassium permanganate titrations, which are part of oxidation reduction, but with potassium permanganate you'll be reading from the top of the meniscus. There's sodium thiosulfate titrations. They're part of oxidation reduction, but sodium thiosulfate is a colourless solution, so you'll be reading from the bottom of the meniscus. And then there's titrations that are related to water. And the water titrations are covered in the videos in the water section. So that's it for this video. Have a read over the learning intention to make sure you understand everything we've gone through.